Hello everyone, myself Saleh Sihag, and today we are going to discuss a structure analysis problem using kanis method. So here it is given this is a sway frame problem and we have to solve it using kanis method. The question is that determine the end moment of the frame shown in the figure. E below E is constant and I value are indicated in the figure. So you can see the figure, it is a beam of length 6 meter and columns are of length 4 meters, where left column is provided a force of 50 kilonewton at the center of the column, and the beam is having a load of 20 kilonewton per meter. So we have to solve it using the Carney's method. The first step involved in the solution of this problem using Carney's method is to calculate the fixed end moments. So calculating the fixed end moment, where start from the MAB. MAB is equal to minus 50 into 4 by 8. This comes by the formula minus WL by 8, where W is the 50 kilonewton load and L is the length, that is 4 meter upon 8, and this comes out to be minus 25 kilonewton meter. MBA is equal to 25 kilonewton meter. MBC is equal to minus WL square by 12, that is minus 60 kilonewton meter, because the W is 20 and the L is 6 meter. And MCB is equal to WL square by 12, where that is equal to 60 kilonewton meter. MCD is equal to MDC, that is equal to 0 kilonewton meter. As we know that at hinge, the moment at hinge is 0, so we carry over the moment AB at BA. MAB is equal to minus 25 kilonewton meter, MBA is equal to 12 plus 2, 25 plus 12.5 is equal to 37.5 kilonewton meter. Now at MAB equal to 0. Step 2 is calculating of rotation factor. Rotation factor, for calculating rotation factor, we need the K, value of K, and summation of K. The value of K is 3 by 4. For member BI it is equal to 3 by 4 I, and for BC is equal to 6 I upon I, that is equal to I. So the summation of 3 I upon I plus I is equal to 7 upon 4 I. The rotation factor, the formula of rotation factor is minus 1 by 2 K upon sigma K, that comes out to be minus 1 by 2 into 3 upon 7, that is equal to minus 0.214. So the rotation factor for member BA is equal to minus 0.214. Similarly, we calculate the rotation factor for BC, that comes out to be minus 0.286, and for CB it comes out to be minus 0.25, and similarly for CD it comes out to be minus 0.25. Now the step 3 is calculation of displacement factor. For calculation of displacement factor, we need to first understand these terms, where what is U, what is LE, what is alpha. So the U is equal to 3 by 4 for hinge spot, and it is equal to 1 for fixed end spots. LE is equal to effective length, that is equal to 1.5 into L for hinged spot, and it is LE equal to L for fixed end spots, and this alpha is equal to reference length upon L effective length. The reference length is LE into R. So now let's see how it is calculated. The displacement factor is calculated. For column BA, U is equal to 3 by 4, that is equal to 0.75, K is equal to 3 by 4, L is equal to 6, LE into R is equal to 6, alpha is equal to reference length of effective length, that is equal to 1, K alpha is equal to 0.75 into I, and U K alpha square equal to minus 0, not minus, it is equal to 0.5625 I, and displacement factor comes out to be minus 0.4. Similarly for column CD, it is calculated to be minus 0.8. The formula for this calculating of displacement factor is equal to minus 1.5 K alpha for sigma U K alpha square. Calculation of story moment. Now we have to calculate the story moment. For calculating the story moment, we have to take first find out the RB and RC. For calculating RB, we have to take moment at A equal to 0. So after taking the moment at A equal to RB into 4, that is equal to 50 into 2 plus 37.5, RB equal to 34.375. Take moment. Now we take moment at MD equal to 0 and RC comes out to be 0. So our story moments comes out to be 37.375 into 6/3, that is equal to 68.75 kN/meter. Now calculation of displacement moment and rotation moment. For calculating displacement moment and rotation moment, we have to proceed by rotation cycle. At first cycle at joint B, M dash BA is equal to minus 0.214 into minus 22.5 plus 0 plus 0 plus 0, that is equal to 4.815. This comes out by the formula. And M dash CB is equal to minus 0.286 into minus 22.5 plus 0 plus 0, that is equal to 6.435. At joint C, M dash CB is equal to minus 0.25 into 60 plus 6.435 plus 0, that comes out to be minus 16.60, and similarly for M dash CD it comes out to be minus 16.60. Now for column, displacement factor is equal to AB is equal to minus 0.4 into 68.75 plus 1 into 4.815 plus 1.5 into minus 16.60, that comes out to be minus 19.46, and for DC it comes out to be minus 38.93. Similarly, we have to repeat the cycle several times, and this comes out to be the irradiation diagram is here, and it is yeah, you can see it. The diagram is we have repeated the steps 7 times, and the final value is approximately equal to their previous values. We have to repeat this cycle as we can repeat this cycle as many times as we want, and mostly we repeat the cycle as till our value comes out similar or equal to the previous values. So as you can see, I repeat this step several times, and these values came for the displacement moment and rotation moment. Now after repeating this for 7 times, calculating the story moment and rotation moment, displacement moment, now we have to calculate the final end moments. Final end moments, the formula for final end moments is equal to find fixed end moment plus 2 into near end moment plus far end moment plus displacement factor, and the values for fixed end moment of MAB comes out to 0. MBA is equal to 37.5, that is a fixed end moment, plus 2 into the near end moment is 12.09 plus far end moment is equal to 0, and the displacement factor is minus 29.84, and the value for fixed end moment of MBA comes out to be 31.8 kN/meter. Similarly for MBC is equal to 31.8 kN/meter. MCB it comes out to be 67.91 kN/meter. MCD it comes out to be minus 67.91 kN/meter. MDC it comes out to be minus 63.8 kN/meter. So these are the final fixed end moment that we have to calculate for this given wave frame.